Now see here, dear students, yesterday we have discussed about the image formation by a spherical mirror and the and the derivation of the mirror formula. Now in this class, we will study we will solve some numerical problem based on the mirror formula. If it is given that, question number 1, in case of concave mirror, this is a concave mirror and its focal length is given 10 centimeter. Focal length is 10 centimeter. This is center of curvature. An object is placed, an object of height 5 centimeter is placed at a distance of, object is placed at a distance of 15 centimeter. Or what is object distance? 15 centimeter from the mirror. 15 centimeter in front of the mirror. What is the question here? An object of height 5 centimeter is kept in front of the mirror and the focal length of the mirror is 10 centimeter. What is this mirror? This is concave mirror. This is concave mirror of focal length 10 centimeter. What is the height of the object? 5 centimeter and the object distance is 15 centimeter. Now here what is the question? Determine the image distance. Determine the image distance, height of image and magnification you have to determine. These three terms you have to determine. First, determine the image distance, then height of the image and magnification. Now, you know the direction of incident ray is positive. So this direction is positive. So focal length is negative. What is focal length? Focal length will be minus 10 centimeter. Object distance negative. Why? Because the direction of incident ray is positive. Origin is pole. Pole we take always as origin. Now, so all the distance measured from the pole, either focal length, either object distance, both are negative. We are moving in negative direction. This is the direction of incident ray. So U is minus 15 centimeter. Now, according to mirror formula, 1 by V plus 1 by U is equals to 1 upon F. 1 by V, image distance. What is object distance? This is minus 15. What is focal length? Minus 10. Now solve this. Minus 15, 1 by V is equals to 1 by minus 10, minus and come this side, it will be 1 by 15 plus. Now what is the LCM of 15 and 10? It is 30. So 1 by V minus and come upside. So 10, 15 LCM is 30. 10, how many times? 3 times. 3 into 1, 3. Minus sign comes here. Minus 3 it becomes. Now here 15, 2 times. 2 into 1, 2. Plus sign is there. 2. Plus minus, minus. Here minus 1 upon 30. Revert this one. V is equals to V by 1 is equals to 30 by minus 1. Minus 1 comes in the numerator. Minus comes in the numerator. This is minus 1. This is what? This is what? This is minus 1 comes in the numerator. So V is equals to minus 30. So we get image distance is equals to what? Image distance is equals to minus 30. Image distance is equal to minus 30. First term we have determined. It means if object is here, minus this side plus this side. This is the origin. So we have already drawn the diagram. So image will be formed somewhere like this. And it will be magnified. But how? We will determine minus 30 centimeter. See here. Now, second term is height of image. You know this formula, height of image by height of object is equals to minus V by U. Yesterday we have already derived, and this is known as magnification. Height of image is equals to height of object into minus v. What is v? Minus 30. Minus 30 upon u. What is u? U is minus 15. Minus 15. What is the height of object? 5 centimeter. Put here 5 centimeter. 5 centimeter minus minus plus into 30 upon minus 15. 15 2 times minus sign comes here, 5 to the 10. It means the size of the image will be, height of image will be negative. So see a parallel focus pole like the image will be inverted. That's why height of image comes out to be negative inside. Height of image is minus 10 centimeter. Now, if you are asked to determine the magnification, then how you can determine the magnification formula? Minus or height of image by height of object. What is the height of image? Height of image is minus 10. Height of object is 5 centimeter. So magnification is minus 2. Minus means, I have already told you, minus means magnification, minus means real and inverted, and 2 means 2 times magnified. 2 times magnified. See here, 5 to the 10. Height of image is 2 times magnified. HI, this is height of image. Height of image. Now, बेटा ये कनकेव मिरर है और ये कन्वेक्स मिरर है, ठीक है? दिस कन्वेक्स एंड कनकेव मिरर. बेटा इसका फोकल लेंथ है 10 सेंटीमीटर. 10 centimeter. This is mirror 1, this is mirror 2. Why mirror 1? Because first of all, reflection takes place through this one. Now see here, this is the principal axis. That is focus point. Now, from the concave mirror, an object is placed at a distance of 12 centimeter. O is placed at a distance of 12 centimeter from the mirror. And the distance between these two mirrors is 30 centimeter. What is the distance between these two? Is 30 centimeter. Distance between mirror 1 and mirror 2 is 30 centimeter. The focal length of this mirror is f2. This is f1 for concave mirror. This mirror is 10 centimeter. What is the separation between the two mirror? What is the separation between the two mirror? 30 centimeter. This is the separation between the two mirror given. And the focal length of concave mirror is 10 centimeter and convex mirror is also 10 centimeter. Now what is the question? To determine the final if reflection first takes place, if reflection first takes place from the concave mirror, takes place from mirror M1, from mirror M1. M1. This is mirror M1 and this is mirror M2. Then from M2. Then from M2. From M2. Find final position of image. Final position of image. Position of image. And draw the diagram. Image. And draw the diagram. Now see here. First reflection takes place from mirror 1. What is this focal length? F1 is equals to 10. F1 is equals to 10 centimeter. Now for mirror 4, how will solve? Solution for mirror M1. For M1 mirror. Here, what is the object distance? Minus 12 given. But here for this mirror, object is here, incident ray will go like this. So this direction is positive. This is the pole. This object distance is negative. What is the focal length? Focal length for concave mirror is negative minus 10. Now what is the image distance? V1, F1, U1. U1 object distance for mirror from mirror M1. Focal length of mirror M1. Image distance of V1. Now can you solve this one? Yes, beta. How we can solve? Apply mirror formula. Applying according to mirror formula. 1 by V1, because we are applying for mirror formula for mirror M1. So we will 1 by V plus 1 by U is equals to 1 by F. Now 1 by V1 plus 1 by U1. What is U1? Minus 12 is equals to 1 by F1 minus 10. Minus come this side, it will be plus. So 1 by V1 is equals to 1 by minus 10 plus 1 by 12. What is the LCM? I think it is 60. 10, 6, yeah, minus 1 comes here, minus 6, 5 times. 5 into 1, 5. Plus minus, minus. So it is minus 1 upon 60 is equals to 1 by V1. So revert this by reciprocating this equation. Image distance comes out to be minus 60. It means minus. It means that if you draw the diagram of this image, the image formed by this mirror will be here. How we can draw? This is the object. If you take the proper distance like this is 10 centimeter, F1, this is 20, this is 30. This is mirror 1, second mirror. Now, for this object, this is focal length, F1. Parallel passes through the focus point. It means it will pass like this. Second one, like this. Now, how we can draw the diagram? From this is the center of curvature. 10 is the focal length. So 20 is the radius of curvature. Draw normal. If it is coming from this side, it will go from this side. 60 centimeters. This is 30. This is 30. Image will be formed at minus direction for mirror 1. This is plus direction. This is minus 60. This is 10, 20, 30, 40, 50, 60 like this. But here this ray will not go like this because there is a mirror. So you put it that dotted line here. Now for mirror M1, what is the image distance? Minus 60. And see here for mirror M2, see here this is the second end. From this object, two rays originate. One goes like this, it will reflect back and meet at 60. Second ray automatically reflected back because this principal axis is normal. The ray which is go towards the normal will be reflected back, and both these will cut here. So image distance form is 60. But this will cut, this two ray will cut at 60. But before 60 there is a mirror, convex mirror. So for convex mirror, these two are incident ray. These two are incident ray, and we know that the point where two incident ray cut or appears to cut, here they will not really cut because there is a mirror and the mirror will not allow the light to move inside. So incident ray will appear to cut. That's why this is object for mirror M2. So what we will say, the image point of mirror 1 act as a object for mirror M2. Write down here. For now, the image point of mirror M1 is the object point for mirror M2. For mirror M2. Why object? Because we know that in previous class I have already taught to you object is a point where two incident ray cut, if cut, real object, or appears to cut. Here the incident ray appears to cut. So that's why for this mirror, this is the object. And what is the object distance? Now for this mirror, this is the incident ray. This is the pole, and the direction of positive direction is along this. This is the direction. See here. For individual mirror, the sign convention will be unique one. For this mirror, since object is this, incident is moving along this. So this direction we have taken positive. This ray reflected, this ray reflected. And over this mirror, incident is going in this direction. So that's why we take this direction as a positive direction. Positive direction for mirror, for which mirror? For M2, second mirror. Now, object distance. What is the object distance? U is, this is 30, this is 30. This is U2 is plus 30. Now, so U2, object distance for second mirror is plus 30. Why plus 30 centimeter? Because we are taking the distance always from the pole, and this is the object for mirror M2. And this direction is in the direction of incident ray. That's why this distance is positive. U is positive. What is the focal length? For convex mirror, focal length is positive because pole, this is in the direction of incident ray. Focus point, so focus point is plus 10. What is the image distance? V2, we have to calculate. Now apply mirror formula. According to mirror formula, 1 by V2, 1 by V plus 1 by U is equals to 1 by F for second mirror. Now, what is the image distance? V2. What is the object distance? Plus 30. What is the focal length? 1 by plus 10. Now solve this. 1 by V2, here plus sign. When this will go this side, minus sign. 1 by V2 is equals to 1 by 10 minus 1 by 30. LCM is 30. 10, 3 ja 3 into 1, 3 minus 30 into 1, 1 into 1, 1. So 1 by V2 is equals to 2 by 30. That is to cut this 15. Revert this. V2 is equals to 15. V2 is equals to 15 centimeter. It means plus 15. It means object is here, image will be formed. This is 10, 20, 30 like this. Let this be 10, 20, 30. Image will be formed at 15. That is here. This is 10, 20, 30 centimeter. Image formed here for mirror M2. Object is here. Now you see here. It will not go this side. It will be reflected back. See here how it will be. I can see any no. See here. This ray which is fall over this will be reflected back because this is going normally. Now where this ray will go? This is 10, this is 20. So this will normal. Draw normal with a dotted line. This is going this side. So for mirror M2, if this is the normal, incident is going from downside, then the reflected ray goes from upside. Angle I is equals to angle R. This produce backward. They will cut somewhere at 15 centimeter, and this image is virtual. So always remember that image distance is positive. That in mirror, the image will be virtual. If image distance will be negative, then image will be real. So see here, the final image forms as how much distance? 15 centimeter from the mirror, 15 centimeter from the mirror. Such type of problem, in such type of problem, it will be given to you that how from which surface the first of all the reflection takes place. Now, so here the reflection first of all takes place from the mirror 1, and then from that is from the concave mirror, and then reflection takes place from the mirror, then the reflection takes place from the mirror M2. So you first apply the mirror formula for mirror M1 and then apply whatever be the image point for this mirror M1 will act as an object for second mirror. And now again by applying mirror formula for the second mirror, we will get final position of the image, that is 15 centimeter from the mirror, from the pole of the mirror M2. Now see here all of you. Now here is another question. This is question number 3rd. In front of concave mirror, determine the two positions. Determine two positions in front of concave mirror so that image will be 2 times magnified. Here the focal length of the mirror is 10 centimeters. Since this is concave mirror, the focal length is minus 10 centimeters. See here, how we will solve this? You know that this is focus point, this is center of curvature. Now if object will be here, what is the condition here? The image is 2 times magnified, 2 times magnified. So see here, according to the ray diagram, when we place any object between C and F, parallel rays passes through the focus like this. Image may be 2 times magnified. So in this case, image will be real. So in first case, you can treat M is equals to minus V by U. In first case, you can take minus 2. Why minus? Real and inverted. Minus V upon U. Now, by using this formula, you can use minus minus cancel out. V is equals to 2U. In first formula, 1 by V plus 1 by U is equals to 1 by F. 1 by V, what is V? V is equals to 2U. 2U plus 1 by U. Don't take U negative because we have to determine the distance U of object. So if some object distance you have to find out, then don't take it negative. Focal length is negative for concave mirror. Now solve this. 2U 1 plus 2 is equal to 1 by minus 10. So this answer comes out to be minus 30 upon 2 is equals to U, that is minus 15 centimeter. U1 is equals to minus 15. Take this as the first condition. First condition. So U1 comes out to be minus 15 centimeter. Now in second condition, as you know, that if we will place object here, then virtual image, if we place object between pole and focus, then where the image will be formed? It will formed somewhere behind the mirror, and again the image may be 2 times magnified. In this case, object is erect. Now in second case, we will take M is equals to plus 2. M is equals to V by U minus B by U. This is the mirror formula for magnification. Now minus B is equals to 2U. Again applying mirror formula according to mirror formula. Again apply 1 by V2 minus 1 upon U plus 1 upon U2 is equals to 1 by V plus 1 by U is equal to F. Apply this, you will get the answer position of object in second case. How you can solve? What is V2? What is V2? V2 is equals to V2, this is second case, V2 is equals to minus 2U minus V2 is equals to minus 2U minus 2U2 plus U2. And what is the focal length? Concave mirror minus 10. Solve this. LCM is, what is the LCM? 2U2 minus and come here 1 plus 2 times 2 is equals to 1 by minus 10. So here 2 comes this side, 10 upon 2. That is u2 is equals to minus 10 upon 2 is equals to minus 5 centimeter. Position of image in this case. So there are two positions. One is plus 5 and another is minus 15 centimeter. Minus 5 centimeter and minus 15 centimeter. So these are the two positions for which the image will be 2 times magnified and